Hi everyone, let's continue with our data structures and algorithm series. In today's video, we are going to cover one of the most important topic in DSA, and that is recursion. Recursion is a process or a function that calls itself. It invokes the same function every time with a different input value until we reach our base case. Base case is nothing else but the condition where recursion ends. To get a clear picture of recursion, we can look at this basic example. As I already have a countdown function that takes n as input, n is nothing else but a number, and the first thing we check is whether value of n is smaller or equal to 0 or not. If it's not equal to or smaller than 0, then we log our number and then we call the countdown again. But this time the value will be n minus 1. And after repeating this process for several times, once our value of n reaches to 0 or smaller than 0, then we simply log done and then return. And that's where our recursion ends. So we can say this condition, if n is smaller or equal to 0, is our base case. I also have a sample output here where n is 4, and you can see first it logs the value 4, and when we call the countdown again with a different input value, meaning the n minus 1, it will make the value of n to 3, and then it will log 3. After repeating it for several times, the value of n will reach to 0, which will hit our base case, and that's where our recursion will end. Now you must be thinking this can be done with loops very easily, right? But sometimes the logic can be very complex. In that case, recursion can be a cleaner alternative to the loops. Now before jumping on to the code sandbox and before solving questions that uses recursion, let's try to understand how call stack works. But why do we need to understand call stack for recursion? In JavaScript or in any other programming language, you must have seen how exactly behind the scene the functions are being executed. Right, for an example, you can see I have a main function here that calls function A, and function A calls function B, and function B further calls function C. For this case, the call stack will look something like this. Because we triggered main first, the first function in our call stack will be main, and then function A, then B, and then C. Now as soon as function C executes, it will be removed from the call stack, and now it will be the turn of function B to execute. Once B executes, then it will also be removed. In the same manner, all the functions that are executed will be removed from the call stack. But remember, all these functions were different functions. But in case of recursion, all functions are going to be same. For illustration, I have an example here called infinite recursion. As you can see, I am only doing a console log and then doing the recursive call. There is no base condition here, which means if I run this, since there is no way to stop, and the continuous addition of functions into the call stack will make the call stack overflow, and your script might crash with an error something like this: maximum call stack size exceeded. You must have seen this in your life once when you hit an infinite loop. Now to save our scripts from crashing because of this error, all we need to take care of is our base case, or the base condition where recursion ends. So that was the reason I was explaining how call stack works, so that we can save our scripts from crashing. Alright, so that's all for the theory part. Now let's move on to code sandbox and try to solve our first question with recursion. I already have the problem statement written here. You can see we need to find the product of all positive integers from 1 to n. Basically, we need to find out the factorial. We already have few examples here. If n is 3, then its factorial will be 6. If n is 6, then its factorial will be 720. Now, I have one of the way to solve this problem already written here, and that is using the for loop. Since factorials always start from 1, we are assuming the minimum result we will get will always be 1. And if we have a valid n, then we will run a for loop starting our variable I from 2 and running it up to n, and with each iteration we are multiplying our result with our I. which means with every iteration it will look something like this, right? Once the multiplication part is done, then we will simply return our result. This can be one way of doing it. We can check the output of this solution in our preview tab. Let me open the console. You can see it is returning 6. Now if I make it 6, it will return 720. Now let's try to solve this with recursion. I will close this preview tab. Let's clear this. Now remember, the most important part of our recursion process is defining the base case. In case of finding factorial, the base case will be if n is equal to 0 or n is equal to 1, then return 1. Else we will return n multiply factorial n minus 1. That's it. That's all we need to do to find the factorial using recursion. Now let's see how exactly it will run. Let's assume the value of n is 3 here. This is our base case. If n is 3, then it will not go inside this condition. Instead, it will come here where we are 3 multiply the factorial of n minus 1, that will be 2. Now let's recall our call stack. In call stack, the first entry will be of factorial 3, that will return 3 multiply factorial of 2, right? The second entry will be of this factorial. It will look something like factorial 2, that will return 2 multiply factorial of 1, right, which is n minus 1. Now the third entry, not the second, the third entry will be of this factorial in our call stack. So I will write here factorial 1. Now see, the base case is our if n is equal to 1, then return 1. Once our call stack executes this one, this will return 1 here and it will be removed from our call stack. I will just write it down here, call stack, right? Now since we have the value of factorial 1, we will replace it with the value. Now once call stack executes our factorial 2, it will return 2, right? Now it will be removed from our call stack. The next execution will be of factorial 3. Now we already have the value of our factorial 2, that is 2, right? Once call stack executes factorial 3, it will give us our final output, that is 6. And that's how our call stack will be cleared and we will get our final output. We can see the output in our console also. Let's open preview tab, console. See, we are getting 720. Now if I make it 3, it will give us 6. So that's how we can utilize recursion in solving our problems. Alright, that's all for this video. Stay tuned for more important DSA concepts, and thanks for watching.